Hi, good evening, everyone. Am I audible?
Yes, ma'am.
Okay. Okay, so today we will cover the week 7 practice assignment. I'll just share my screen. Okay, is it visible to you?
Yes, ma'am.
So this week is mostly about dictionaries, right? So I hope you know the basic characteristics of dictionary. So can you name few? What are dictionaries? Okay, you can try telling me what type of elements are stored in a dictionary, in what format,
Dictionary are generally in the form of key value pair where each key represent a value.
right? So in case of a dictionary, can it have duplicate keys?
No, ma'am, it should be unique.
Right, but values can be duplicate, right? Okay. So there are a few functions that we will see, like dot keys will give us what keys of the dictionaries in the form of a list. Uh, okay, is key is one more function. So is key checks whether something is a key of a particular dictionary or not. So you have to give those two parameters. Okay, so let's start with the questions. So this is the first one. The following pseudocode is executed using the scores dataset. What will be represented at the end of execution? Okay. So scores data set, everyone remembers that we have the student data set basically, and the fields in each card is the name of the student, date of birth, marks, city, town, and the card number, right? The sequence number. Okay. So first we have an empty dictionary D, then we are running a while loop. So to read all of the cards in this deck. So you read the first row in table one, then you check. See, this is the is key function. So here, the card that I've picked, I am extracting the town city attribute from there. And I'm checking if that attribute, whatever the value is present in that attribute in this card, is a key in dictionary D or not. Right. So if is key, that means if this town city is a key of dictionary D, then this expression will give true. Right. Otherwise, it will give false if it is not a key. So if is key is true, then will come into the nested if statement. So here we are checking now for this particular card, you're going to check if the physics marks is greater than whatever is stored in D of town city. So for example, if I have a card, let's say physics marks is 80 and the city town is, let's say, Bangalore, right? So is key D town city. So see, initially D is empty. If this is the first card that I pick, then is key will give true or false.
What, ma'am?
So this is the first card I'm picking. Okay, so D is currently empty. Now if I run this function, if is key D of town city, that means whether the current town city of the card is already a key in dictionary D, but dictionary D will
No,
be
no, ma'am. It's not in dictionary because the dictionary is empty now.
right. So is key will give false value, right? That means we cannot move further into the nested if. Okay, so we will go to the else part and we will create a key value pair for this particular city. Now the key is going to be the town city. So inside D now we have one key and one value. So the key is town city, that is
And
Bangalore, right? That
and
is
the value is 80.
yeah. So the value is the physics marks for that card, which is 80. Now let's say the second card I pick is of a person who has scored 90 in physics and from Bangalore only. Now you again check if is key. Now this will evaluate to true, right? Because we already have a key for Bangalore. Now come inside the nested if. Now here you're going to check what is the physics marks of this card, 90. Is it greater than whatever value is stored in terms of the key in the dictionary D? So the key is VLR and then the value is 80. And my current card value is 90 physics marks, right? So 90 greater than 80. So you're going to update the value. So now the dictionary is updated here instead of 80. Now you have 90. Okay. Now let's say third card that I pick is also from a student from Bangalore, but they have scored 75. So now will I update this town city is to value?
No, ma'am. No, ma'am.
No, right? So this will only update when we get a higher value. So like this,
Ma'am,
I will,
here can the value will be changed for the city or town? Like it is Bangalore for the three of cards. And if it comes Chennai or Madurai,
yeah, yeah. Like, see, if the fourth card I pick is from, let's say, some student who scored 65 from Chennai, right? Then you will just create another key here. After Bangalore, there will be one more key for Chennai. And whatever the current value is, you'll store it if it's the first entry for Chennai, right? Then next, whatever Chennai cards come or whatever Bangalore cards come, we will only update the value if it is greater than the current value that is stored. So like this, we'll do for every city in my deck of cards, right? So
okay, ma'am.
from this, what do we get? A dictionary D, which contains what? The keyword unique city name, right? From my deck of cards. And the corresponding value for each city is the highest physics marks from that city.
Yes, ma'am.
Yes, no? Right. So the question is asking what will B represent? So next part of the codes, the while loop ends here. Okay, now it is the next part of the code is. So we have a variable A assigned 0 and B is an empty list. Now for each key in keys of D, what are the keys of D?
The name of
Bangalore,
the city.
Ma'am. Yes.
Whatever city towns are there, right, in
Yeah,
my
ma'am.
deck. Okay. So now for each of those keys, we are going to check if D of that key, like for example, let's say key is Bangalore. So D of Bangalore, whatever marks is stored there, highest marks in Bangalore, is equal to A. So if it is equal to A, then you will add it to B as an element. But let's say initially we're starting with an empty list B and A is 0, right? So let's say the first city I get in my key list is Bangalore. So for that, I have seen 90 is stored. So is 90 equal to 0? No. So the if statement, first if statement will not execute. Then come to the second one. Is D of key greater than current A? So 90 greater than 0. Now A will be set to that D of key value. That is 90 in this case. And B will be assigned the key. So in this case, that is Bangalore. Right. Now, let's say the next city that comes here in this for each block, it's Chennai. So in Chennai, some person has scored, let's say, 75. That was the highest. In that case, again, now you check. D of key is now 75. Is it greater than current A?
No.
No, ma'am.
No. So nothing will be changed, right? Now, let's say we get one more card from Bombay. So Bombay person has also scored, let's say, 95 he has scored. So now D of key is 95. Is it equal to A?
No, ma'am.
No.
No.
Greater
So again, first if block doesn't execute. Second one will execute 95 greater than 90. So now your new A value is what?
90.
95 and
95.
B is
Bombay.
B is a
Bombay.
list, basically list containing Bombay, right?
Yeah, ma'am.
Okay. Now let's say the fourth card I pick, okay, is from someone in Kolkata. That person has also scored 95. Now see D of key value is 95, A is 95. So now first if block can execute. So
Yeah.
now your B will be appended with one more element. So now it was Bombay. Now it also has
Bombay.
Kolkata. Okay. Now let's say I pick a card from Delhi. So that person has scored, let's say, 98. Now, which of the if statements will execute, first or second?
Second.
One second.
Second one. So, second one does what? Will it add Delhi to the list B?
No, it will change.
No. It will reinitialize list B and now it contains only Delhi, right? That is city with the current highest marks. And A is D of key, so A will be now 98. So, from this code, what is B representing?
City that
The
scored highest
number of
marks.
city towns with equal scores.
Okay. Listen now, I will say it, you tell me if it's right or wrong. So I think B is representing a list of city or cities which have scored the highest marks in physics, right?
Yes,
Yes, ma'am.
that's statement.
Because it can happen that the highest marks has come from more than one city. So that's why the append statement is there in the first if. And in every time that you find a higher marks, you will reinitialize the entire list because now you have a new city which has that highest marks, right? And if you find any other city having that equal highest marks, you're again going to add, right? So it can be a single city or it can be many cities who share the highest marks. So which option? First two options can we eliminate?
Yeah, it's not number, it is list of cities.
Right. So which one
C.
C.
is the correct one, right? Not equal marks. We will take the equality only when it is the highest, right? When two cities have the highest marks and both are equal. In that case, they'll be in the list together. Okay. Any doubt in this question? Anyone?
No, ma'am.
So questions 2 and 3 are again comprehension type. So common data. Following pseudocode is executed using shopping wheels dataset. What will A represent at the end of execution? Okay, so shopping wheels, we know there are store names, items, categories, quantity, price, customer name, all of this information is there. So initially D is empty, empty dictionary. Now your while loop starts here and it ends here on line 11, right? So this while loop will go through all of the shopping bills dataset cards. Now you read the cards each one by one. First statement you check is if not is key. So if is key returns true when a key is part of a dictionary, then not is key will return true
It's not part of the dictionary.
when it's not part of the dictionary. Okay. So the first if statement is a negation. That is not is key if the current card I have picked. If the shop name is not already a key of dictionary D, in that case this will return true and you will create a key, right, for that shop name. And the value will be assigned as an empty dictionary. So for every new key that you create, the immediate value is an empty dictionary. Right. Now this if statement is executing for every card, right? So many customers have shopped from the same shop. So there will be distinct keys for every shop name in dictionary D. Right. Now for each item in item list, see this is also happening for every while iteration. So we will run a for each block and each of the items in X dot item list. So the current card's item list will go through the items one by one and we'll check if D of shop name of item, that is, this is a nested dictionary now, right? Nested dictionary is
Yes,
what
ma'am.
here now I have dictionary within a dictionary. So the outer dictionary keys are what shop name. So might be Big Bazaar is a shop name. So that is the key. Against that we have another dictionary. This dictionary contains what?
Items.
Yes, correct. Unique items.
Yeah, ma'am.
Unique items and
Like food, apparel,
value is
and yeah.
Value is
value is a
true.
boolean value. Right. Initially, see, this for each block is basically checking whether an item in the current card's item list. For that, it is checking whether it is already set to true or not. Right. I'm sorry. This is for each block. So we are setting the value true for every item in the item list. So here, maybe some item one, the value will be set to true. So for every card, we'll go through all the items and we will create this key value pair. Right. Okay.
I have one question.
Hmm.
For a key to be present in the dictionary, does it have to have a value assigned to it?
Yeah. Yeah. Key value has to
Otherwise,
be
it will.
together. Yeah, if it contains a null value, I mean, then there is no cause of keeping that key, right? Because you are using the key as an identifier, as an index to reach the value. Okay. Uh, yeah. So here for every, let's say I have picked a card. Let's take a card, for example. This is from Big Bazaar. Some customer XYZ. They have, let's say, bought bread, pen, shirt. Okay. Three things they have bought. So initially our dictionary D is empty. So Big Bazaar is the first shop name. So is it a key? No. So we'll create a key. So now dictionary D looks like Big Bazaar and an empty dictionary is set as the value. Right. Now go through each item in X's item list. So what are the items? We have bread. Against that the value will be set to true. For all of them, create this key value pair. and for should also it will be set to true. So this is how your dictionary looks like. Now let's say the next card you pick is also from a customer who bought from Big Bazaar only, but they have bought bread.
Different items.
Yeah, let's say they have brought bread and oil. In that case, how many new key value pairs will be added to the Big Bazaar list?
Oil only.
Only oil will.
Only
Only
oil, because
oil.
we can't have duplicate. That's correct. Okay, so when is not is key going to give false?
When the item is present in the dictionary
No,
or
when
that
is
shop.
not is key? See the line 4. Not is key. It's checking what?
Is the dictionaries
If
is
this
the item
shop
is in the
name,
dictionary? Yeah, ma'am.
yeah, is the shop name present as a key in the dictionary or not, right? Is key gives true
Ah,
when it
yeah,
is
yeah.
present.
Shop key, yes,
Not
yes.
is key will give true when it is absent. So not is key gives true when it is absent. So when will
Shop
it give
name is
false?
the shop name is absent.
So not is key
When
will
shop
give
name is
false
present,
when, yeah.
the shop name key
So
is
that means
present.
that means when I go, like I said, that if I pick another card from Big Bazaar, then it will not create a new key value pair. It will just run the for each block and add the new items into the already existing dictionary. Okay, so this is what the while loop is doing. So if I have three, let's say, stores in my data set, then how many keys will be there in the outer dictionary D?
The number
I
of
have,
shops.
correct.
As many as can.
Number of different shops.
If I have n different distinct shops in my data set, then D dictionary, outer dictionary will have how many keys? N.
Yeah,
And
ma'am.
Right. Every distinct shop will have a key value pair for itself. And the value part, that is the inner dictionary, contains what? All the distinct items that have been purchased from that shop. Correct. Now,
yes, ma'am.
see, after this part, now come to line 13. Now your while loop is over. So now you have a variable A set to 0. Now you're going through each of the keys in dictionary D. So again, you know what dictionary D each means. Now you're checking if A is less than length of keys of D of A. Let's say the first D of A is Big Bazaar. So in that case, what are the length of the keys of D of
Four.
A?
Four.
What is the length?
Number of unique
4. We
items.
have 4 items. Correct. Number of
Items.
Yeah,
unique
ma'am.
items. That's the length. Right. So if it is less, if it is greater than the current A, then you set that length to A's value. Now let's say the next shop is V stores. There is a shop like that in your data set. And let's say it has 6 different items. Okay. Then A value will be changed to what? Initially it was 4 because of this
And it
4 items.
changed to 6.
It changes to 6. But now let's say we have one more some XYZ store next, which has 3 items. For that, will it change A value?
No, ma'am. It will not change, ma'am.
No.
No.
It will only change when we get a
For the
greater length,
maximum
right?
number of items.
Right. So now what is A representing in this whole code? You
Maximum
see the
number of
options.
items.
See.
Maximum number of items.
Unique
Option
items
A.
because
Unique
Yeah.
items.
D. Option D.
B.
Okay. See. First thing that we can eliminate is option C. Because nowhere I have mentioned categories in the code, right? So get rid of that. Next, option A is saying maximum number of items sold by a shop. So number of items doesn't mean unique items, right? Some two, three people might have bought the same item. It is counted 3 times, and
option B
that's
is
not the
there.
case. Right. So let's eliminate D. Then maximum number of unique item categories. Again, categories is there, so you can eliminate. So B is the correct one. Maximum number of unique items sold. Okay. Anyone has a doubt here?
No man.
Okay. Now, question 3 is based on the same data. So consider the dictionary D created in the previous question. So remember that dictionary in your mind. The outer dictionary keys are the shop name, inner dictionary key value pairs are the unique items sold from each shop. Right. So now consider that dictionary created in previous question. What will item list store at the end of the execution? So now item list is a new list we have initialized here. Now L is containing keys of D. That means L contains a list of unique shop names. So for each A in L, that means for each unique shop name in L, M will contain the keys of D of A. So let's take our previous example. This is D. Big Bazaar is a shop for which we have some, let's say, A, B, C, D, four items. Imagine the true values. Okay, I'm not writing it. Again, we have SV stores. For that, let's say we have E, F, G, H, I, J. Six values I have. That is six unique items these are. And again, some XYZ shop I have. For that, I have three items. This is my dictionary D. So for each A in L, the first A is Big Bazaar. So M is containing the keys of D of A. So M contains what? M is what? A list of A, B, C, D. Correct?
Yes, ma'am.
What will A L contain? What is the rest of L?
And the keys
BCD.
of D,
Only
It
B,
will
C,
drop
D.
the first.
B, C, D.
Yes.
Yeah.
First one. In it means it will drop the last one. Now go into a nested for each block. So for each B in L. Okay. So each B in L, that means first B is the small b. N contains keys of D of B.
Ma'am, it contains the items
Items for B,
for the big for the shop
EB.
name.
Okay. Let's check this again. Each A in L. Okay, L is keys of D. That means A is the shop name. So keys of DA is the item, right? And L is rest of L. That means now, sorry, this is wrong. I have written rest of M. Okay, rest of L contains what? The first Big Bazaar is out, so now the next shops are there.
Second shop name onwards.
Right. So now for each B in L. The first B is this. Next shop is VS. N is keys of D of B. So this entire list. E, F, G, H, I, J. For each, again nested iteration, for each I in M. M is what? Keys of D of A. This ABCD. This first dictionary, nested one. So now pick each item from here. So first item is A. Right. For each I in M, first item is A. For each J in N, what is the first item? E.
A.
E.
So yeah, ma'am. E.
E. Right. Check if I is equal to J. That means, is there an intersection between these two nested dictionaries? That is there any common item? When will
That
I
is
get this line 10 if statement is true? When between two shops there are at least some common items, one common item. As many common items, that many times the if statement will become true. Right. For
Yes.
example, if in SVS, here I have taken all distinct, right? In case of E, if it was A, then I equals to J would have been true. Right. And if it is true, that is, if we find one such common element between two shops, right, then the item list will contain that element. And then we have exit loop. So, what is exit loop statement?
to break the loop after getting the value what we want to get.
First condition is met, it will exit the loop.
Okay. Give me just a second. Yeah. Am I audible?
Yes,
Uh,
Okay. Yeah. So exit statement Do you know the difference between break and exit these statements? Okay, so here, since it is not the exit statement that we actually use, it is written exit loop. That means exit this innermost loop, right? Well, which is the innermost loop? At which line is it present? This line 9 is for each block.
It's,
So
yeah,
what
ma'am.
we have understand is this item list will contain what type of items? Items that are common between two shops.
Yeah, ma'am. Number of common items between the shops.
Okay, just see this. Which option do you think is correct?
E,
Mm.
A, A, B, C, D. Which one?
D, D.
Mm.
Last one.
The last one.
D.
Two shops. Okay, let's check. So it is D. Why is it at least? Because those items will be considered even if they're common between all three shops, right? So at least two. It can be between Big Bazaar and HVS, and it can be between Big Bazaar, HVS, and the other XYZ shop also. So at least two shops is the correct one. This is good. So now you have learned to differentiate between that at least at most thing from here. Okay, so just because we came to this exit loop thing, so I'll just tell you in brief what is break, what is exit statement, because later on in Python and all we'll be using it. So break is a statement that we use to break out of a loop, right? If I'm using a for loop and I use the break statement, that if some condition is satisfied, I'm using break statement. That means now I don't have to continue with that loop anymore, right? And exit is a statement that terminates the entire program, right? Wherever you find exit, it will just end, no more execution after that. But break will continue the execution after coming out of the loop that it is enclosed inside. Okay, there is also a statement called continue statement. So continue is just a little different from break. It will break out of the current iteration of the loop and continue with the next iteration. Okay, but here you don't need to know all of that. Okay. Okay, this is now using the words data set. What will D represent at the end of execution? So words data set, we know it is containing, every card is containing a word. It's part of speech, its letter count and the sequence number. So D is initially an empty dictionary. Now while table 1 has more rows, so you go through all of the cards. Every time you read a card, I is set to 1. So I is a variable which is always reinitialized at the start of every iteration. Now there is an inner while loop. Inside you have I is less than equal to x dot letter count. That means I is 1, whatever is the letter count, it will go up to that. Right? Why is it not less than? Because that won't cover the letter count, right? Because I is not starting from 0. If it started from 0, then 0 less than letter count would work. If it starts from 1, it has to be less than equal to. Okay. So this loop will iterate as many times as there are letters in your current card, the word in your current card. A is set as the ith letter of the word. So let's take a word. Let's say girl is a word. Now here I is set to 1 initially. What is the letter count? 4. So I will run as long as I value doesn't exceed 4. A is ith letter of the word. First iteration A is what? G.
G.
Now if not is key D comma A. What does this mean? I'm saying currently this is my first iteration. So you know D is empty. So what will is key give? Is G a dictionary key of dictionary D?
No, ma'am.
No.
So is key returns true or false?
False.
Just is key will give
False.
false. Not of
False.
false is true,
Yeah,
right?
ma'am. It's
So
true.
this is basically the not is key statement. So every time you see that it is a new key in the dictionary that does not exist, so you create the key value pair. So now inside dictionary D there is a key value pair like this. G is to 1. Right. Else, if it is already a key, right? In that case, you just increment the value.
Mm.
So that means in this example, I cannot show you, but okay, if I had an example like this, soon. So in that case, dictionary D will be updated like this. For S, there will be the value will be 1. Then for O, the value will be 2, right? Because it will increment the second O. The second time you find the O, it will not create a new key value pair. It will increment the existing one. And for N, there will be another one, this entry. So basically, what is D of A storing for any letter in a word? It is storing the number of
Sequence of the
occurrences of that letter.
Count of the number of letters.
Okay. But now, again, see, is D a nested dictionary?
No.
No. That means these key value pairs are the only key value pairs present here. That means every alphabet from every word can occur only once in this dictionary, right? Will be only one unique occurrence of every alphabet in this dictionary. Because this dictionary is being created from all of the words in my data set. It's not like word wise I'm having a separate dictionary. The dictionary is just the alphabet, right? Those are the keys, and corresponding letter counts are how many times those letters have appeared throughout the data set. Because after this we are just incrementing I and going for next iteration. Okay, and this we will be doing for every word in the data set. So D is a dictionary containing unique alphabets as its keys, and the corresponding value refers to letter count of how many times that particular alphabet has occurred throughout the data set. Is it clear?
Yes.
Yes, sir.
So what is the question is asking, what will D represent? So D, I told you what it is. Now tell me the option. This is very easy to
Option C.
A.
A option,
No, no.
frequency count
Frequency
of each.
count of
A,
each letter.
right? Option C will not be there because it is saying most frequent letters. Now that will require a separate condition. You have to check the values, like whichever are the highest values in the data set, you have to separate them into a different dictionary. Then it is most frequent letters. But we are not doing all that. We are just keeping a frequency count of each letter in the word set, how many times it has occurred. So option A is correct. Now 5, 6 are again comprehension type. Okay. So the following pseudocode is executed using library dataset. What will D represent at the end of execution? The library dataset is your books and authors, published, year, all of those things, genre. So D is initially empty dictionary. Now in a while loop, we are traversing the library dataset. Every time you pick up a card, you will check if is key D comma X dot author. That means my current book. Okay. Let's say I have picked up a book of Sherlock Holmes. The author is Arthur Conan Doyle. So initially, if this is my first card, is Arthur Conan Doyle a key in the dictionary? No. So is key will give false. So come to the else part. Create a key, and what is X dot here? The published year, that is at which year the book was published. So let's just take a random year. I will say the dictionary now looks like this. So Arthur Conan Doyle is a key as an author, and the year is let's say some 1920. Okay. Now, yeah, sorry, you're asking something? Oh. Now let's say the next card that I pick is also some other XYZ book of maybe some other Sherlock Holmes book of the same author, right? Again, check if is key. Now this will return true or false.
True.
True. Because we already have that author as a key. Now you come to the nested if and check what is the year that is there stored against the value. It's 1920. Right. So if this particular book, the second one, if the year here is 1910, so in that case, the if statement will be true and we will update this value to 1910. So when is the update happening for an author? When you are finding a book that was written even before, right? Even before the current year
Yes.
value that is stored. So this will happen for every unique author in library dataset. So for every unique author, what am I storing as the value?
Please, will you explain again?
He- Here we are just creating a dictionary of author and year of publishing of that author's, a particular book of that author's. So here is the condition that if a key is already present for an author, that means we already have a key value pair, we have already seen a book of this author. Now my parent card is also from the same author but a different book. Then I'm coming into this line 5 nested if and checking what is the current publishing year value stored under this author and what is my current card's year value. So whichever is the smaller year value,
Lower.
that means whichever is the earlier one, will be updated. Okay.
Okay,
So the
nice.
question is, what is this dx of author for any author? What is it storing?
The earliest year a book was
The
authored.
earliest publication for that author, right? So which option? So you have to just give what is this D entire dictionary. What is it representing? Not for a particular value.
Each author and their earliest
Mhm.
book.
Dictionary with authors as keys mapped to the year of publication of their first book. Okay. Um. So this
Option B.
option B is the answer. The others, how we can eliminate? First one, dictionary with authors as keys mapped to the year of publication of latest book. So if we wanted to do that in our code, what has to be changed? Only one thing.
The
Line
sign.
5.
So here you
This
just put
Equality sign.
line 5 here.
Less than
Line
sign.
5 here.
right,
Yeah.
just a less than sign would do it. Okay. Next is saying dictionary with authors as keys mapped to the year of publication of their second book. That also can be done by keeping max and second max. And dictionary with authors as keys mapped to their year of publication of second latest book. Okay. So obviously B is correct. Okay. Any doubt here?
Ma'am, how can we modify it? Excuse me.
Huh? Sorry.
By how can we imply, ma'am, option C in the given code?
See, in that case, you
What
have
can
to
we?
uh, for every author, you then have to maintain two key value pairs like this. Right. You have to maintain the earliest and the second earliest. So that will be the highest one. I'm sorry. If you want earliest or latest, you want latest, right? So publication of their second latest, if I say, then you have to keep track of what is the latest and what is the second latest. Both you have to keep updating throughout the data set, right? For every author. So that will require nested dictionary will be better for that. And uh,
Oh,
this second one, option C, that is their publication of their second book. Same way you can do. You can just keep track of the earliest and second earliest. So second earliest is the second book. That means second minimum and minimum. Understood. Like that three prizes problem. There we used to have three minimum maximums, right? First max, second max, third max for every subject. So we had top three marks for every subject. Like that you can do it.
yeah, and we can also calculate by this method in the score dataset first, second, and third toppers
Hmm. Same
by
thing.
calculating the total marks.
Yeah, you can use dictionaries to do a lot of manipulation.
Yeah, ma'am, yeah, got it. Thank you.
Okay, so 6 is also based on that same question. So now you know what D dictionary is storing for every author, the earliest published year. So consider the dictionary D created in previous question. What will A represent at the end of execution? So A is 0 initially. Then for each K in keys of D, what are the keys of D? Unique author names. Okay, now for each author, you're going to check if D of K, that is year of earliest publication, is greater than A, and you update A accordingly. So at the end of execution, A should store what? I think the options will help a
Latest
bit.
year,
See,
most recent.
B.
publication year of the first book across library dataset. Okay.
It's
Any
A.
other option? Publication year of the most recent book, which is also the first book of an author. Okay. Anything else?
Option C, publication year of the most recent book across the library dataset.
Okay. So only D is left. Anyone wants to say D? Okay. So let's eliminate one by one. I'll start with B. So publication year of the first book across the library dataset. Right. So first book means what? We want to check the minimum most, right? Here, what sign do we have? Greater than. If we have a greater value, then we're updating. If you flip this, then this is the first book across library dataset. So, first book written by any author, where the dictionary itself is storing the first publication of every author. So, that will give you the earliest book. Now, option B is eliminated. C is publication year of the most recent book across the library dataset. This is easily eliminated. Why? Because recent book means what? Across the library dataset, that is the highest year value. But when we created D dictionary, we didn't take that. We took the lowest year of publication, right? So most recent is not even in that D dictionary. Most recent is a different value, that is the current book published, like recent most book published by an author. That should be a higher year value. So your C is also eliminated. Now D, year of publication of latest book by an author which is published very early. So this is obviously not straightforward answer because it is ambiguous. What is very early, right? You can't say that. You need a concrete statement. So first option A is saying it is the publication year of the most recent book, which is also the first book of an author. So why this is correct? Because of the last part. See, here only you can see that the integrity is there. My D dictionary was storing the first book publication year of every author. And now I'm checking the highest year among those. That means whatever is the recent most year among those, that will be my answer. But it is still a first publication for an author, right? So A is correct. Is it clear for everyone the reason?
Yes, ma'am.
Okay. Any doubt? Any other doubt? All right. This also, no, this, yeah, this is also comprehension. So from dictionary, you might get comprehension questions in quiz 2 also. Uh, the following pseudocode is executed. Now we are again having force data set. What will CTD of K represent at the end of execution? So CTD is a dictionary. We can see we want to see what any key of this dictionary represents, right? So we have one while loop here. Everything is inside that while loop only. Okay. So you read the card one by one, and first thing you check for every card is if the town city is a key of CTD. Okay. If it is a key, then you enter the next nested if. Otherwise, you come to the else part. That is this. You create a key value pair for that town city, and the value is going to be an empty dictionary, and then you fill out the empty dictionary with a gender value of your current card, whether it is male or female, and the corresponding physics mark. Understood? Now, this is the initial thing. If some city is not there in CTD, then you create this key value pair and populate it with the gender value of your card and the current physics mark of your card. What happens if the key you picked is already a town city? In that case, you come into line 5 and check is key D of X town city, comma X dot gender. That means now you're going into the nested dictionary for that city. What gender value is stored? Is it already filled out for both male and female? Or let's say my current card X is containing male gender value, but for city D, whatever this city is, let's say Kolkata, for that only the key female is present in the dictionary, in nested dictionary, then this will give false. But if male is present, this will give true. So if the gender of your current card is already a key of the nested dictionary for that city, in that case, you come to line 6. Now you check what is the mark stored. So we are always storing the physics marks, right? So if the mark stored is lesser than my current physics marks of my current card of the same gender, okay, then you update the mark.
Can you take the
So
examples?
yeah, now I'll
Uh,
take the examples. Now let's say I got the first card. It is from Kolkata, male student, got, let's say 60 in physics. So city D, first tell me it is first card. So is it a hit? Is it a key? Kolkata is a key? No.
uh,
Come to line 14. Create the key. So for Kolkata now I have an empty dictionary. Inside empty dictionary, what should I store? Gender
Physics
and
mark.
physics marks. So male and 60. This is the current card I have. From that, I got this information. Next card, let's say I get for Delhi, I get a female student who has scored 70 in physics. So now CTD also has a key for Delhi, where the key value pair is female and 70. Now let's say the third card is again from Kolkata. It is for a female who has scored 80. So line 4 is correct. It is already a key of CTD. Kolkata is already there. Line 5, is the gender a key of the inner dictionary? Is there an entry for female?
No,
Ma'am.
ma'am.
Kolkata, there is only one entry, male 60. Right. So since there is not an entry, so we will come to the else part. Create an entry. So now Kolkata will change from male 60 was there. Now there will be one more entry,
Female 8.
female 80. Okay. Now let's say fourth card I pick is again from Kolkata. This is of some female who has scored 90 in physics. So now line 4 is satisfied. Yes, it is. Kolkata is a key. Line 5 is satisfied that gender female is a key in Kolkata's inner dictionary. Now line 6. What is the mark scored currently for that gender? 80. What is the marks of the current card? 90. So is 90
90.
greater? Yes. So now this will be changed to 90. Like this, same thing will happen for every cities. Basically, we are calculating the male and female physics mark for every city. What marks? The highest physics mark, right? So for every particular city, city D contains what? These are unique cities in my sports data set. Values are, there are nested dictionaries which contain 2 entries only, because in our data set we have only 2 specified genders, male and female, right? So in the inner dictionary, there will always be only 2 key value pairs for any city. What are the values against each gender? The highest marks that has the highest marks in physics that has been scored by that gender in that particular city. Is it understandable?
Yes, ma'am.
Yes, ma'am.
Okay. So it is asking that for any city K, what is city D representing? That means what is this inner dictionary that is being stored for any city K? So what is the correct option?
D.
A dictionary with gender as key mapped to the highest marks in physics scored by that gender in city K. So this is correct. Others are wrong. Why? First one is saying a dictionary with gender as key maps to physics marks. This is not specifying anything. C is a dictionary with gender as key mapped to lowest physics marks. So to make it lowest, again, what line should be changed?
The equality sign. That operator.
This, line 6.
The sixth line.
Here we can have a lesson sign, right? Greater than sign. So this one is wrong. D is saying a dictionary where cities as keys mapped to physics marks. Again, A and D are very vague, so you can easily eliminate these. B is the correct answer. Any doubt in this? Anyone?
No, ma'am.
No, ma'am.
Okay. So now remember this dictionary. Okay. And I think it will be used again in 8. Yes. So consider the dictionary city D we created in previous question. What will A and B represent at the end of execution? This type of questions always save your time, right? Because you only have to go through one code block, one main code block. So always try to finish the comprehension questions. So A0, B0 initially, 2 variables which are both set to 0. We have to say what they represent. For each I in keys of CTD, what are the keys of CTD?
The name of cities.
Unique city names. Okay. L is what? That list of keys. It is, I'm sorry. For each I in keys of CTD, that is for every city, let's say I is currently Kolkata. For that, L is what? List of keys of CTD of I. So what are the keys of Kolkata? Nested dictionary
Gen-
contains
Gender.
male and female, right? So L will be what? M comma F. Okay. If first of L is M, First of L is M means first element is M in that case. So how does this order appear? So that will be based on what card we picked first, right? What gender card we picked first. In that order, we have the dictionary values, key value pairs. So if first of L is M, that is M is the first entry. In that case, if city D of I, again, city D of Kolkata in this case, first of L, which is M here. Okay. You will check if this, whatever is stored against it. So in our example, I think, yeah, we stored 60, right? Let's say that is the highest value boy scored in Kolkata. So CTD of I, first of all, for Kolkata gender M will be 60. Is it greater than CTD of I last of L? So last is obviously female,
And yeah, ma'am.
right? And that is 90 in our example. So this fails. A will not be incremented. When will I come to this else? When first of L is not M. When female is the first of L. So for some cities, it can be like this also, the entries. First, I got a female's card, right? So in that case, you will come to the else part and do the same checking. That basically, it is a whole roundup way of checking that inside every nested dictionary, which gender has the higher mark, right? If males have the higher marks, you increment A. Every time you find a male dominating a female's marks in a particular city, you increment A. Every time you see a female's marks dominating the male marks, you increment B for any particular city. So now you can tell what is A and what is B. So which option is correct? First, see the first three options if anything is correct. For every city, we are checking which gender has chosen, got the highest mark. If it is a boy, add it to
Option
A. If
A.
it is a girl, add it to B. A is saying number of cities from which a male student has scored the highest physics marks than female is stored in A, and B is number of cities from which a female student has scored highest marks in physics than male. Okay, so you're saying A. Anyone else is saying any other option?
A.
Okay, so B and D can we directly eliminate? Because it is not the number of students, right? Here, the entries are city-wise. So for a particular city, we are checking, not for individual student, male and female. Okay, so B and D are easily eliminated. A and C. So C, what is the wrong thing? That it is just reversed, right? So A is scoring for males. Here it is given as female. That's the problem. So A is correct. Any doubt here?
No, ma'am.
Ma'am.
Okay, so 9 and 10 are again individual questions. Let's go through one by one. So 9 is saying the given pseudocode is executed using a dataset having the same fields as the words dataset. So we have done many questions like this before. Same field means now we have a paragraph or a couple sentences given to us. That is our new dataset. But it is exactly like the words dataset where each card is made up of one of the words, right? Like she is a card, sells is a card, like this. And all the parameters are also same, the part of speech and letter count and everything. So let's see the code. It is asking us what will be the value of word count at the end of execution. So word count is initially a value variable that is set to 0. Right. Word count is a variable set to 0 while loop is now starting at line 2 and it ends at line 8. So while loop is traversing through the new data set cards. And for every card you read, you are calling this procedure, right? Inside an if statement, you are calling if get something and the parameter is the current card you're passing X. Whatever value this procedure returns, if it is greater than or equal to 2, in that case, word count increment. So now the whole thing is you have to decode the procedure. So now every time you come to line 4, the control shifts to line 10, where you execute the procedure definition. So for every card, any card Y, what is this procedure doing? It has I set to 1, letters is a dictionary, and C is an empty string, right? So again, we have a while loop, which is going to run from I is equal to 1 to the letter count. So since we are starting from 1 again, the equal to sign has to be included for all iterations to happen. So Let's take our usual word soon. Okay. What is letter count? 4. How many times will loop iterate? 4 times. So first iteration, C is the ith letter of Y word. What is C? H. Okay. C is H. If C is vowel, okay. So if C is a vowel, then in letters dictionary, you set the value of C to be true. Okay. So in our case, is S a vowel? No. Nothing will happen in letters dictionary. Let's say this is our first iteration for the first word. Then it is empty yet. Now when I go for the second word, uh, I'm sorry, second letter in the same word. So now your C is O. Is it a vowel? Yes. So letters is now O set to
True.
true. Correct. Next word is also O. Will there be a new true key value pair? No.
No.
Same one. Right. And last one is N, which is also not a vowel. So only this for this particular word. And now you are returning what? See, here the increment happens for every iteration. Now what you are returning is length of keys of letters. So for this particular word, what is the length of keys? 1.
1.
Yeah.
There is only one key. Is it greater than equal to 2? No. So it will
No.
not be
No.
added in word count. When will it be added? When the return value is greater than equal to 2. Greater than equal to means what? At least or at most?
At least.
At least. That means where this procedure returns a value that is at least 2 or more than 2. When will the procedure return such a value?
When the word count or the
2 vowels.
When
vowels
there are
are,
at least 2 distinct vowels. 2 vowels is present in soon also, but we didn't get it, right? There has to be distinct vowels because distinct key
yes,
value pairs. So if I had this word, let's say amity. Here, will it give word count a chance to increment?
yes, ma'am.
Because A and I are there.
A and
Right.
I.
So this will get something will return true, 2, which is greater than equal to 2. So now what is word count then for this particular uh, data set we have to check. Okay. So now you just need to seek out the words which have at least 2 distinct vowels. So first one is not, second one is not, third one is there, fourth, fifth is not. So we got one word, 2 words, um, 3 words. Seashells, for this is a separate card only. Okay,
Yeah.
so
E and
4.
A.
Oh, and the sure last one.
Sure, this is also there, right? So we have 5 such words which have at least 2 distinct vowels in them. So the answer is 5. Is it clear?
Yes, ma'am.
Okay. Last question. So this is again on your scores data set. Let MPC be the lists of the sequence numbers of students who have scored more than 80 marks in mathematics, physics, and chemistry. MPC are 3 lists which contain the sequence number of students who have scored, like for M greater than 80 in M, right? And for physics and chemistry, similarly higher than 80 marks they have scored in individual subjects. Now, at the end of execution, dictionary 80 stores a dictionary with the sequence number of student mapped to the number of subjects in which the student has scored more than 80 marks. That means a person. So first you tell me that this MPC, these 3 lists, can they have intersections?
Yes, ma'am.
Yes, right? Because a student can score greater than 80 in 2 subjects or all 3 subjects. So
Yeah, ma'am.
intersections might be there. So we have to see that at the end of execution, this dictionary 80, this should be a dictionary which stores sequence numbers of students as the keys. And they are mapped to what? The value. The value is what? Number of subjects in which they have scored more than 8. Okay. So if a person has scored only greater than 80 in maths, then for that serial number, let's say some serial number 5, for that, what will be the value? 1. If some serial number 6 has scored greater than 80 in both maths and physics, but not in chemistry, then for them, the value is 2. Like this, unique serial numbers are the keys, number of subjects is the value. Okay. So you have to choose the correct implementation of this procedure n sub. Okay, it is an MSQ. So we have this code given, dictionary 8 is an empty dictionary. While loop is to traverse through your sports data set. Every time you read a card, you create an entry in dictionary 80 for the unique sequence number of that card. The sequence number is always unique for every card, right? So if there are 30 cards, there will be 30 entries in this dictionary 80. And the corresponding value you're storing is n sub procedure, in which you're passing the sequence number of the student as a parameter. So now this n sub should do your work of finding out in how many subjects this person has scored higher than 80. So check. First option is saying count should be kept, which is set to 0 initially. If we check, n is what? Sequence number of the card. If we check that the sequence number is a member of list M, that means he has scored greater than 18 math, increment count by 1. If it is a member of P, also greater than 18 physics, increment by 1. If it is member of chemistry, also increment by 1 at the end, return count. And if a person has not scored greater than 18 any of the subjects, count will be 0. Is this correct?
Yes.
Yes, looks correct
Yes,
only.
ma'am.
Let's see the other options also. In this one, what is different? Here we have this. So we don't have a return statement, right? No, we have. It is on the next slide. So here, up to this, everything is same. Then we have one more if condition checking if count is greater than equal to 2. So this will filter out those people for whom. Count is greater than equal to 2 means what? That for a person, if he has scored greater than 18 more than 2 subjects, 2 or more than 2 subjects, at least 2 subjects,
At
then
least.
only true will be returned. But again, check, is my goal to return true or false? My goal is to return the number of subjects, right? So from the return statement itself, you can eliminate this option. We don't want Boolean value. Is this correct? N sub is a dictionary, it is saying. First of all, how can you eliminate this? There is no procedure definition. It is taking N sub as a dictionary, but it is a procedure, right? So this is inherently wrong. This is also inherently wrong. You don't even have to check these two because there are no procedure definitions or return statement. So option A is the correct option. Let's still check one. Hmm, okay. Yeah, is this clear for everyone? Any doubts? Okay, I guess no doubts then. So that's the last practice question. Okay, only 10 questions are there. So now you can do your graded assignment. And if you have any doubt, you can ask me. Okay, and in the next class, I think that is on Monday, we will be discussing the activity questions from this week. All right, so anyone has any doubt, anything you want to ask? Yes, are you saying something because it's not audible to me?
Ma'am, is there any revision session of the week 7 has been planned by you or any
Yeah,
team?
like before quiz 2, we will be taking instructor sessions only for your revision. Okay.
No, not before Q2, but in this week.
No, no, this week revision session we don't do week wise. Revision session we do before the exams, right? Week wise session, there will
Okay,
be 3
ma'am.
sessions per week. So for week 7, you started yesterday, the theory was done. Today, practice is done. Next day, activity will be done, and you can ask doubts.
Ma'am,
Okay,
in
ma'am.
quiz
Thank
2,
you.
the syllabus for the quiz 2 CT is from week
Weeks
1 to
1 to 8.
8.
Yeah,
Yeah.
first 8
So
weeks.
what will be the proportion of that's
50 to,
like
yeah, so 50 to 60% questions will come from 5, 6, 7, 8, these 4 weeks. Okay.
and ma'am, one thing that I want to ask, which
Hmm.
students are eligible for OPPE after the quiz 2
There
it
is,
is or
no, no, for CT, there is no P exam.
okay, ma'am.
Okay, yeah. All right. Anything else?
Yeah, ma'am. I often confused about the OPP one. What is, ma'am, this exam?
OP is an online proctored programming exam, right? So you will have that exam for courses like Python, Java, C, DBMS. These courses have OP. So CT doesn't have OP. In foundation, you only have OP in Python. Okay, so
Okay,
next
ma'am.
term you will be
And
having.
ma'am, I have another question about the paradox event.
Hmm.
May I ask?
Yeah, you can ask, but I don't have much idea. So you can ask.
You have already joined so many times, so I am asking about the experience.
Okay, okay. Yeah, the experience is very nice. So if you're you should definitely plan to come this year.
Yeah, ma'am.
So there are
Uh,
multiple workshops from different professors across IITs and other institutes, also triple ITs. So those are very informative. You should try to join as many as you can.
yes, ma'am. Ma'am, is every student is allowed in the paradox 26?
Yeah, like our students who have already qualified, the qualified levels are done, they are definitely allowed to come.
Oh. And what's the terms and conditions of which students those participated in that
Uh,
by any role or responsibilities?
I think that they will give you a code of conduct that you have to maintain while you're on campus. Right. So those things, if you want information, you can ask the support team once or whoever is the secretary of your hall, like them you can ask.
Okay, ma'am.
Okay. Yeah. So tomorrow's session, please join for the activity questions. Then we'll start week 8 next week. Okay. And also try to solve your graded assignment if you can before tomorrow. Then if you have any conceptual doubts, you can clear out. All right. Thank you, everyone. Thanks for joining. Have a good night.
Thank you. मैडम जी भाई
హలో. ఏమో డాడీ మామ అమ్మ టిఫిన్ ఏంటమ్మా మనకి. ఓయ్ తొందరగా చెప్పు, ఆయన బండి మీద ఉండి అడుగుతున్నాడు. ఉప్మా రవ్వ ఇత్తరా లేకపోతే 2 ఇడ్లీలు అండి తెచ్చుకో. మాటకి చెప్పింది. నేను క్లాస్లో ఉన్నాను డాడీ. ఏదన్నది ఒక 2. ఏంటి ఏంటిది ఇప్పుడు తీసురాడు ఆయింట్మెంట్ అంట. అపాయింట్మెంట్ పేరు లోని ఆమె ఇది వచ్చిన నువ్వే వేయాలి. మీరిద్దరే చూసుకున్నారు నాకెందుకు. ఆమె అయినా నీకే చెప్పొద్ది. తెట్టే తీసిరా, నీ దగ్గర డబ్బులు ఉంటే తీసిరా డాడీ. మరి వచ్చాయి నాకు ఆగలే. ఆ? ఉప్మా రవ్వ. గోధురావు తీసురా తీసుకొస్తా. డాడీ మరి ఈ ఉప్మా బాగోద్దు డాడీ. సర్లే ఏదో ఒకటి తీసురా. కార్తీక్ తో మాట్లాడుతుంది నాతో కాదు. 20 రూపాయలు పట్టలేదంటే గిట్లే ఎండ తీసుకురామంది. అదే అక్కడ అక్కడ ఉంటాయి కదా డాడీ. అటు పోలీస్ స్టేషన్ దగ్గర అది 30 అంటావా. సర్లే తీసుకో ఏదో ఒకటి తీసురా డాడీ. నేనేం చేయను. అమ్మా నువ్వు వేస్తావు ఉప్మా రవ్వ తెస్తే. ఆమెకు అసలు ఓపికే లేదంట. తిప్పుతా నాదేముంది. రైస్ అంటే ఉందామా. బాయ్ రైస్ ఉందా అయిపోయిందా. ఆ, ఉందంట. లే ఒక ముద్దన్న వండుకుని చేసుకుందాంలే తీసురా. చిరాకు వస్తుంది ఎంతసేపు మాట్లాడతాడు నీ ఫోన్లో ఉండి. ఆ, ఒక మాట సరిగ్గా చెప్పవు. అసలు ఎంత తీసుకొస్తుందో తెలుసా బండి మీద కూడా అట్టగా అంటాడు అని. సరిగ్గా మాట్లాడాడు. ఒక్క దెబ్బ నీతోనే. Hey, hey. संजय राघवन ఏమా మూసుకోండి మర్చిపోయా. నా- బాగా చెప్తున్నా. అయిపోయింది. ఏంటా చదివేది? అక్కడ ఓ, ఆ, ఇవన్నీ తీయక్కడ ఇంట్లో పెట్టాయి. ఏహే పక్కలో అంటే మెంట్లో వచ్చేద్ది.
Hello, sir. Hello.